Good afternoon, everybody, and welcome to the North Carolina Museum of Natural Sciences virtual Triangle SciTech Expo. My name is Greg Scoopy, and I'll be the host for today's program. Before we get started, I just want to send a big shout out to our sponsors, the NC SciFest and the Biogen Foundation. Without them, this presentation and the rest of the week would not be possible. We're coming to you live today from Zoom as well as YouTube. For our friends watching on Zoom, just a quick tutorial. Closed captionings are available for you today. All you have to do is click on the CC button there at the bottom of your screen and then select Show Subtitles. For optimal viewing, we recommend using the side-by-side mode. You can change your speaker view by clicking on the View or Speaker View button at the top of your screen and then select side-by-side mode. You can also adjust the size of the slides or the speaker by clicking and dragging on the bar there. And then lastly, we want you active in the chat. So go ahead and drop all your questions and comments in there for Dr. Porter. To get that chat going, we want to know, why do you love the environment? Why are you here today to learn more about how we can help fight climate change? So drop your answers in there and we'll get that chat going. So it is my pleasure to introduce Dr. Dan Porter. Dr. Porter has a PhD in environmental toxicology and a master's in environmental assessment from NC State. He has 26 years of teaching secondary science.
Yeah, there's no one else here from our class yet, so.
He has 26 years of teaching secondary science, is in the chair of the department at Cardinal Gibbons High School. He's also super active in climate research, and in fact was one of the first cohorts for the Climate Rheology Project that worked very closely with Al Gore in 2007. Welcome, Dr. Porter, and I'll go ahead and stop sharing my screen and you can take it away.
Okay, thank you very much for inviting me and allowing me to share Earth Day with you. Yeah, my background is actually started in 1995. I started to realize that we started to see some interesting things in Long Island Sound where I grew up, and we started to see androgynous fish migrations. After that, I just pursued a career in science because I really wanted to do something that would try to improve the environment and help the planet. My motivation, let me see if it's not advancing for some second. Let me see what's going on here. Let me stop share. Let me reshare. Let's see. There we go. There it goes. All right. So one of my motivations is I like to fish with my son. In 1970, a company named Ward's Transformer, if you're familiar with Cary, this is Lake Crabtree Park. They spilled thousands of gallons of toxic chemicals called PCBs into the surrounding area, and it just mitigated into the whole creek and started to cause disruptions. My son and I on weekends, we enjoy fishing, and we go to the lake and we see this sign here, and he always asks me, he's only a 10-year-old, and he asked me, he said, "Dad, why can't we catch the fish and cook them up?" And I have to explain to him kind of the basics about chemicals and really why back in 1970 people didn't care about the pollution when they were doing this action by Ward Transformer. So, you know, this is something I want to preserve the future for him and also care about the environment today for futures to come. So this is the most downloaded photo. It's called the Blue Planet. It was from Apollo 17 in 1972. When I look at it, it reminds me that we are all connected and that the Earth is finite. Today, I wanted to go over 3 questions about climate change. Must we change? Can we change? And will we change? The first question I want to address is, must we change? Really, what is going on with the climate? And, you know, what is the current situation? This is the atmosphere. This photo was taken from ISS. It really shows how thin the atmosphere is. The troposphere, which is the layer that we live on or live in, actually is 5 to 9 miles thick. And you can kind of see that we are just blanketed by a very thin layer of gas. This is the basics of greenhouse effect. It's extremely important to our planet. Without the greenhouse effect, we would actually be frozen like Mars at certain times and actually baking in the sun at others by solar radiation. The greenhouse gases in the atmosphere do help us maintain a constant temperature. And then the shortwave radiation comes in from the sun and it hits our surface and it bounces back as long wave radiation. The radiation basically excites the molecules that are greenhouse gases, and this is what causes the Earth to warm up. So currently we are spewing out 152 tons of greenhouse gases every day. These greenhouse gases include CO2, methane, CFCs, chlorofluorocarbons, and other gases. So there's many sources for these greenhouse gases. This includes burning of fossil fuels, transportation, the oil, the gasoline, the coal, and natural gas. A lot of thawing of the permafrost definitely has a positive feedback to the greenhouse gas emitted, like methane as well. So the largest source of global greenhouse pollution is the fossil fuels. Over 10 billion metric tons of carbon is emitted each year. And as a result, the accumulation of greenhouse gases, the global temperatures have risen dramatically. 19 of the 20 hottest years ever measured with instruments have occurred since 2001. The hottest was 2016. As you can see here is the last hottest 5 years. Last year in 2020, we tied the record for the warmest year. The average global temperature has risen more than 2 degrees. So one of the things I wanted to address, and I get this question a lot, is okay, doesn't the Earth heat up and doesn't it cool down naturally? And the answer is yes. We have Malaykovic Cycles, a scientist who discovered that the Earth's precession or the tilt impacted it, and also the distance away from the sun. But what we look at is really what happened in the past. And as we can see here, these are the data from the ice cores. Now we use ice cores to look at how much CO2 and also the crystallization of the ice. And we can go back in time, really seeing what was the Earth's past. What I really want to concentrate on right here, and I don't know if you guys see it, but right in here, this is the spike. The current ppms, or parts per million of CO2, is 419. Okay, so if you actually took a meter outside, on average, it'd be about 419. And this can vary depending on location based on a couple of variables. But we're at 419 parts per million of CO2. I want to spend a little bit of time on this, and this is really important. This was from the latest UN report. And Dr. Pollack, who's going to present later, also is going to have this because both of us really wanted to stress kind of what is the models showing us based on our current projection of CO2 emission and global greenhouse gases. So if I take a look here, this is a 2016 estimate, but if I extrapolate the data, you can actually see right in here, we are following that red line right here. We are right in here. So when we follow that red line, you can actually see that we are actually looking at a temperature increase globally. This is globally, okay, of 3 to 5 degrees Celsius and plus. Now the base case scenario, if we start radically lowering the CO2, as you can see, this is net zero down here, okay, we would still have an increase of around 1 to 2 degrees Celsius. So, and there's numerous reasons for this because of the persistence of CO2 in the atmosphere as well as other greenhouse gases. But it's very important to get a metric based on these models. And this is kind of like, you know, the hurricane models, when you guys look at where hurricanes are going, they have different projections based on different variables and scenarios. But right now we are actually going toward this number here, which is pretty scary. So when we take a look at the Earth, it's 71% covered by water. So the oceans absorb about 93% of the extra heat, and that can radically impact a lot of marine life, but also certain types of patterns of precipitation. So this heat makes the ocean storms like hurricanes, typhoons, stronger and more destructive. 1/2 of the increase of the global ocean heat content occurred in the last 20 years when we look at the data. And we all know in North Carolina, we know the destructive force of hurricanes. This is Hurricane Florence in 2014. I'm sorry, in September 14, 2018. And you can see the size of it. So the extra heat is also disrupts the water cycle. The water vapor is carried over the land and then creates much more precipitation events. This leads to flooding and erosion issues. The extreme precipitation events have produced more severe weather events throughout the world. This is a supercell formation over the plains of Montana. And, you know, we all see the local flooding events in Raleigh. I'm all too familiar with this because part of my background is I spent 5 years as a chair for the Stormwater Commission of Raleigh. And we would actually try to tackle numerous goals to try to say, okay, how do we lower the impacts of flooding for the city of Raleigh, as well as encourage growth. So I'm definitely aware of these events. And if you live near Lake Crabtree, you know that the mall is right next door and is notorious for flooding. Some people ask me if climate change can be blamed for more precipitation events and droughts at the same time. Well, what happens is that the land is pulled of its moisture through evaporation, and then the heat actually will accelerate that and will encourage more droughts. So what we're seeing is more extreme droughts events throughout the world and the US. This is just a small snippet of a drought condition. It is also based on human consumption and aquifers, but you're going to see just not a moderate drought, but more extreme droughts. So the hottest temperatures have a direct impact on the fire frequency. The fire season in the Western US is more than 100 days longer than it was in the 1970s. And this is causing a lot of property damage in certain parts of the Western US, as well as Australia, as you guys have probably seen in the news as well. So in 2016, this is a fire that was in Alberta, Canada, caused 100,000 people to evacuate. And it was one of the most destructive fires in the tar sands of Canada. So the worldwide weather events from 1980 to 2019, as we can see here. 2018 caused about $160 billion in disaster loss. 2019, $140 billion in disaster loss. So you can see the increase right in here. So due to the continental ice sheets melting and the thermal expansion of the oceans, and thermal expansion is basically when the water molecules heat up, they get further apart, and you do get a increase in sea levels. So we see the correlation between the continental ice sheet melting and sea levels rising dramatically. So all the coastal cities, Miami is actually #1 at the greatest risk by asset. And you can see New York is #3 in Newark area. This is directly related to sea level rise. Even in New York, they're looking at building a wall and construction of a $1 billion project with a wall around Wall Street. That way it doesn't flood and protect the financial district. The U.S. Department of Defense has long warned about climate change and even has long-term plans for certain coastal bases in trying to lower the impact to the military infrastructure. And then certain diseases that rely on mosquitoes as vectors. This is the species of mosquito that transmits the Zika virus. And they're starting to extend their ranges and due to the warming and temperature changes on the planet. Climate change and other environmental factors as far as deforestation and habitat loss are contributing to the worst mass extinction since the dinosaurs 65 million years ago. So, you know, it's staggering when you look at 50% of all land-based species are at risk. So The World Economic Forum says climate change is the #1 threat to the climate economy. So when we look at the carbon cost, you can see that there is a lot of impact to it. And when you look at how much is actually going to be impacted by the carbon footprint of everybody on the planet, it's the #1 threat to the global economy. So must we change? And obviously, I think everybody on the video could definitely conclude we must change. Yes. So the second question is, can we change? And I'm going to address basically how we can change. And, you know, there's always solutions and a lot of hope. I'm not all about the doom and gloom. I like to find solutions as a scientist and try to say, okay, what do we do about it and how do we fix it? So here are some of the solutions at hand. When we look at the renewable energy, wind was projected to provide about 30 gigawatts of electricity by 2010. As of 2019, we exceeded that prediction by 22 times, which was amazing. The growth of wind energy is growing exponentially, as you can see from this curve. Wind energy could supply 40 times, and I want to stress that, 40 times more electricity than the entire world currently uses. So if we actually harnessed every single aspect of the wind 40 times over, and that's a pretty amazing stat. In North Carolina here, we're expanding wind energy off our shore. The project is called the Kitty Hawk Wind Farm, and it could produce 2,500 megawatts of energy. And that's enough to power 700,000 homes, which is pretty amazing. Now, I do get some questions sometimes about, okay, what's the impact to migratory birds with wind and other animals, and also noise. I actually drove by a couple of out toward Iowa where my brother lives, and they can be quite noisy. But what you see with the current technology is that they are tweaking the rate of rotation to allow birds not to be impacted as much, as well as minimizing the noise impact. So solar is even more dramatic story. 20 years ago, the best projection is that we would install 1 gigawatt of solar capacity by 2010. In 2010, we exceeded it by 17 times. In 2019, we exceeded the goal of 121 times. PV installations have exponentially grown around the world, as you can see here, and it's definitely going to continue in the future. And part of this is because the cost has come down. When we look at the 1976 cost of close to $80 per watt, we were limited. And also when you take a look at other technologies, compared to, let's say, cell phones or everything else, the cost has dramatically dropped. So it's less than 25 cents per watt, which is amazing. So solar is like the perfect solution for many countries where there is no universal electrical grid. This also lowers the impacts from local wood burning and deforestation. That way they can actually use electricity for certain cooking and other devices in their remote areas. So this is something I want everybody on here to listen carefully, because this is another important stat, just like the wind stat. Every hour, the Earth gets as much energy from the sun to run the entire global economy for a year. So I would love to see a lot of this energy that's hitting our planet be harnessed for energy consumption. So when you look at the electric vehicle market, the sustainable revolution has totally shifted the transportation, and it has grown tremendously. It wasn't just the Tesla or other, you know, the Volt or any of those. Every single brand is looking for a future in EVs. And now there's a massive incentive to even promote possibly tax incentives to EVs even more than what's currently available. This is current news. I imported this because it was just in the newspaper, and I thought it was very interesting because, you know, me being a school teacher, one of the biggest emitters of greenhouse gases is busing and transportation, without a doubt. So when we take a look here, the North Carolina High Point Thomas buses are looking at electric buses as an option. And here's the vice president actually touring the facility. So can we change? It's, what are we going to do about it? And can we change ourselves as a species on the planet? And the answer is yes. Okay. So will we change? That's the big answer. When we take a look, I really implore you to use your voice, your vote, make choices that will help, combat climate change and to preserve the future. The science is clear. I know President Biden has his plan, and I know he released an Earth Day type of proclamation about the U.S. trying to cut the emissions by 2030 to reduce a runaway global warming and climate catastrophe. So the world does depend on you. So how do we do this? How do we get involved in really at the local level, but also at the state and federal level? How do we get involved? And this is really important because I think it's all up to all of us. The organization I've been involved with since 2007 was the Climate Reality Project. Like Greg said, I was one of the first cohorts. And after Al Gore lost the presidency, he concentrated his full efforts on trying to solve this climate crisis. So I was part of that group, went to Tennessee and started to get trained in all the different types of climate solutions out there. How to do presentations, become an advocate, being involved, being a leader in the local area in the chapter. So this is an organization, if you want to, you can actually talk to me more about it. I am the co-chair right now of the Durham chapter. Also, I work with other groups. Another local and grassroots environmental groups is the Sierra Club. When you take a look at the Sierra Club, they do a lot of meetings, they lobby, they sign petitions, and they are very strong activists for certain politics. When you take a look at their influence, it's amazing. And you go to meetings and you actually meet a lot of people that have similar thought processes, or if you want to learn more about it and you want to learn about certain topics, they're a great group as well. So changing your diet, this is something that I definitely need to do myself because I do like going out for a steak, but every time I go out for a steak, I have to reflect on really what is the impact. Changing to more of a lower trophic level diet, plant-based than meat diet will have a dramatic impact on the greenhouse gases produced. Why is that? Well, because the meat products use a lot of land. They also use a lot of water. They take a lot of processing and transportation, and they produce a lot of animal waste. So if you're eating lower at the lower trophic levels, you'll actually end up helping the environment significantly. Planting a tree, something I did this week in numerous locations, but just trying to get involved at the local level. The Nature Conservancy has a tremendous goal of planting 1 billion trees in a campaign to offset it. Do trees provide a carbon sink? Of course they do. They also improve the aesthetic value of an area. They also lower the urban heating effect, which is the energy in the heat produced from the dark surfaces like asphalt and everything else. They can lower that by cooling. So trees do act like a carbon sink, and they can significantly help offset it. Making smarter consumer choices, lowering your carbon footprint, buying local. I pass the farmers market all the time, and supporting local produce versus international produce can definitely lower the amount of CO2 needed in order to buy your products. Sustainable products, looking at certain types of products, where they come from, what kind of gases they actually emit themselves, whether it's CFCs or any other things, but also looking at your footprint, your carbon footprint for your house in electrical use. Is there a better way to use the electrical use, whether it's a certain type of smart device in your house, will definitely impact it. And then this is the big one that I do a lot as a climate activist, is I contact my local representatives. I try to work with local city councils, like in Cary, Raleigh, any of the areas around here. I talk to my county officials and state and at the local level and the federal level. David Price actually was able to give us a video. I just definitely want to make sure everybody understands that this video was showing the no opinions expressed from the museum or from myself. This is from his own, but I just definitely want to make sure that you understand that when you look at what needs to be done, certain bills need to be passed at the federal level. And you definitely need a voice and try to advocate for that. So I'm going to play his video, just kind of show you a demonstration of what certain politicians' point of view is.
I'm David Price, representative in Congress for the 4th District of North Carolina. And it's great to join you today for this celebratory virtual event. Earth Day's become one of our largest annual events, with hundreds of millions of people around the world gathering to renew their commitment to a healthier planet and to urge policymakers to take immediate action to deal with the impending climate crisis. We're marking the 51st Earth Day celebration. And at this point, it's undeniable that climate change remains our greatest intergenerational challenge.
Yep. Mm-hmm. Oh, I'm sorry. I didn't know. Yep. Okay. How about that? There you go.
Question about it. What we do today will ultimately set our path toward ecological healing and the survival of our planet, or the opposite of those things. The global climate crisis isn't just a matter of higher temperatures and rising sea levels, although it certainly is that. The current agricultural and environmental impacts alone are devastating. It also poses a great threat to public health, which has become particularly apparent as we continue to battle the COVID-19 pandemic with our global partners and neighbors. One study recently conducted in over 3,000 counties across the U.S. found that long-term exposure to airborne pollutants worsened the severity of COVID-19 and significantly increased the risk of death. In fact, our new Environmental Protection Agency administrator, a proud North Carolinian, Michael Regan, referred to the combination of the COVID-19 pandemic and the environmental crisis as a perfect storm. While the public health and environmental crisis we currently face endanger all Americans, communities of color are disproportionately at risk. Deliberate policy decisions in the past targeted communities of color, like the Jim Crow practice of redlining in housing policy. And as a consequence, a disproportionate number of Black Americans and communities of color have been forced into areas with high levels of pollution and environmental contamination. To be effective, our current and future environmental policies must have an eye toward our nation's history and must prioritize environmental justice. You may know that the U.S. environmental justice movement is said to have begun in Afton, North Carolina, where thousands of gallons of oil containing toxic chemical compounds called PCBs were dumped on a state highway starting in 1978. Warren County, which had a majority Black population and still does, was selected as the site to dispose of contaminated soil. This move triggered a wave of demonstrations and the subsequent arrest of high-profile activists who tried to block the PCB-laden trucks at the entrance to the Afton landfill. Ultimately, the soil was dumped into the landfill, and it contaminated the water supply. However, these demonstrations spurred a larger movement to address the impacts of toxic waste and industrial activities on low-income and communities of color. Some of you may also remember Hurricane Floyd, the national attention North Carolina got back in 1999 as the storm battered the state and overflowed the lagoons, the open waste pits used by hog farmers, and polluted the surrounding communities. Now, this has occurred numerous times in the 20 plus years since. Communities across the state, particularly disadvantaged and communities of color, have borne the brunt of the illnesses caused by polluted water supply and noxious odors from animal waste. I introduced the Sustainable Waste Infrastructure and Natural Environment Act, we call it the Swine Act, to develop a standard environmentally sustainable technologies, or a range of technologies, for animal waste management across the country and to protect the surrounding communities. This legislation would be just one component of the vast and urgent policies needed to advance environmental justice. We simply have to do more. Despite stalled economic activity in many parts of the world, the World Meteorological Survey found that greenhouse gas production and global temperatures continue to rise to record levels in 2020. So we're at a defining moment. The countries that work to address climate change will be the countries that lead in the 21st century global economy. Due to decades of lobbying by special interest groups and more recently by the ascendance of climate deniers to the highest levels of government, the United States is not currently positioned to lead as we might in clean and renewable energy. Over the past 4 years, the Trump administration undermined widely supported scientific evidence demonstrating the immediate and long-term dangers posed by climate change. This was part of a sustained campaign to roll back critical environmental protection measures. One such action aimed, unfortunately, at EPA's Science Advisory Board, their autonomy. It effectively censored agency scientists. I'm a member of the House Appropriations Committee, and in that role, I introduced and Congress subsequently passed an amendment to the 2021 government funding package that prevented this anti-science rule from going into effect. Scientists at the EPA, therefore, can freely pursue and use sound research to fulfill their mission, protect the public from environmental threats. Thankfully, now we have a brighter outlook with the new administration ahead of us. On President Joe Biden's first day in office, he signed several executive orders to help reposition our country as a leader in climate solutions, both at home and abroad. Not only did he follow through on commitments to rejoin the Paris Climate Accord, President Biden has brought the climate crisis into the national security sphere, creating the special presidential envoy for climate, who will have a seat on the National Security Council. So that signals a whole of government approach, which is exactly what we need to meet this moment, with recognition of the role different branches of the federal government play to mitigate climate threats. Particularly the investments the federal government makes in America's workforce and infrastructure now will determine our environmental and economic sustainability for many generations to come. I'm once again serving as chair of the Appropriations Subcommittee on Transportation and Housing and Urban Development. We call it THUD. And I've long advocated to elevate funding for renewable energy technologies and electrified public transportation, just to name a few of the policies we underwrite. Scientists agree we have to drastically reduce emissions from transportation and power sectors, the two leading sources of global warming emissions in the United States. We've made some progress, incremental progress over time, despite some extraordinary obstacles. But increased investment is necessary. Hopefully now we make more than incremental progress to substantially transform our workforce, our technology, and our infrastructure. The Biden administration has set forth an agenda to develop and deliver clean energy, to maximize the resilience of land and water resources, to protect communities and the environment, and to advance environmental justice. North Carolina, we're familiar with the destructive byproducts of climate change. We've witnessed countless superstorms destroy some of our state's most vulnerable ecosystems. And every year, hurricane season becomes more threatening, often more destructive and capricious than in the past. I'm grateful for the leadership we have at the state level. Governor Cooper and his team have demonstrated their commitment to keeping North Carolina safe, rising to unanticipated challenges. These recent catastrophic flooding events underscore the need, I think, for cost-effective, predecessor pre-disaster mitigation, pre-disaster management strategy to safeguard our infrastructure, our businesses, our communities, as well as to conserve taxpayer resources so we're not having to come in with disaster funding crisis after crisis. I've reintroduced bipartisan legislation in this Congress that would direct federal agencies to consider and plan for future flood risk in whatever they do. We call it the Flood Resiliency and Taxpayer Savings Act. We want to leverage the best available data to mitigate flood risk and to shield communities from future damage. We do have a president, I believe, who heeds scientists' directives, who believes in science, who has set out to reduce carbon dioxide emissions and other greenhouse gases by 80% so that we can avoid some of the most dangerous global climate catastrophes. And as one of the largest emitters of greenhouse gases in the world, in global coordination efforts. So here it is, Earth Day, 2021. What an opportune time to commit ourselves to these objectives, to take stock of where we are, and to renew our nation's commitment to pursue a healthy and just environmental future. Thanks to everyone on this call for all that you do. I'm David Price.
So as you can see, reaching out to certain political entities and politicians can help try to make a change. And also just trying to encourage action to happen at any level. And that's really important. All right, I am actually done. If you have any questions, Greg, do you want to read any questions that you have, and I'll try to answer them?
Sure, we have a couple in the chat. Let me get you pulled up here on screen alongside me. So this is in reference to the ice core that contains some of that historic data. Jessic was asking, because of climate change, aren't we going to lose that ice that contains all of that information?
We are. Matter of fact, that's one of the things that the National Climate Data Center wants to preserve. So what they're doing right now is trying to take as much data, because you're exactly right. It is melting certain parts, and we need to preserve that data of CO2, the size of the crystal formation, the gases that were trapped in the air at certain time periods, and that's really important. You're exactly right.
Okay, thank you. And then Elizabeth wants to know, what would happen if Antarctica melted? Would certain countries flood? Well, on current models, it would be a catastrophe. If Antarctic, there's a big difference, and I want to make sure everybody understands this. The ice that is in the Arctic Ocean, it's kind of like ice cubes that are in your glass. If you have, let's say, melting of the ice that's in your glass, you don't see the glass overflow, and that's an important distinction. But when you see the melting of a continental ice sheet, now you're adding meltwater to the ocean. Current models, would have dramatic impact to the planet because of that continental ice sheet melting, and we are seeing it. We are seeing it melt. We do see some areas that were positively adding ice, and that was due to certain polar vortices events and cool air being drawn down at certain areas. Antarctica had some, but they're becoming more and more less common. Okay, well, then we have another question about weather. So Sophia wants to know, can the excess formation of clouds resulting from increased precipitation, warmer bodies of water, possibly combat the excess UV rays Earth receives from the disintegrating ozone layer?
Yeah, so a couple things. Yeah, NASA's got a lot of Earth observational data on the water vapor layer because it will slow down the heating of the planet. As you guys know, when you have more clouds out, you're going to get less heating. But certain UV radiation will make it right straight through the clouds and actually reach the planet, and you do end up having almost like a thermal effect also with clouds. So there is a lot of research being done with how much cloud formation there is, and there is even different I mean, I went to one seminar, it was kind of interesting with possibly almost like the seeding of clouds, trying to encourage, that. But there's a lot of data that needs to be gathered as far as how much we need to do that. The ozone layer is a different type of problem. As students know, maybe that are on the call, the ozone is actually formed from nitrous oxides, which is a greenhouse gas from cars, as well as volatile organic compounds. These VOCs are emitted from plants naturally, but also human beings can be. And that's producing ozone. Now, there's bad ozone and good ozone. Ozone at the stratospheric layer protects us, thank goodness. Otherwise, we go outside right now on a beautiful day like today and fry like an egg. So the Montreal Protocol back in 1989 was a very significant event. And that was really the hope for the planet, honestly, because that was a good example of where we could solve a problem. So the hole in the ozone started to shrink because we banned the CFCs, and also VOCs. So when we take a look at that, that's actually really important emissions. Mm-hmm.
All right. Ryan and Oliver both want to know, if climate change keeps going at this rate, are we all going to die?
I wouldn't be that morbid and down, but definitely what we need to do is by 2050, and I come back to that one model that I spent a little bit of time extrapolating the data on, you will see different latitude zones change radically in certain areas, more than others. And if you wanted to research a little bit more, you will see that, you will see almost like a Miami type of temperature for, let's say, North Carolina coastline compared to the mountains. So that you'll see dramatic changes, and there are certain models out there that maybe are a little bit more site specific. But as far as everybody dying, I hope not. And I'm going to do whatever it takes to try to help solve this problem with you. So we need everybody to help that.
I hope that's not the case either. Let's see. I know there's a lot of students watching today. What would you say to the folks watching at home who live in the house but don't own the house, or who eat groceries who don't do the grocery shopping? What can young people do to help fight climate change?
What I would do is become involved. There's certain organizations you can always ask your teacher about, okay, what's the science, and learn more about it. And, do it at the appropriate level, because, sometimes if I use language, you may be like, what is that? Positive feedback loops. It wouldn't be appropriate for grade school. So what I would do is I would actually try to, ask your teacher about more information and certain resources. NASA, NOAA, the certain government agencies have a ton of cool citizen project. I know the museum even has some cool citizen project stuff that you can do. So when you look at getting involved, you can get involved at any age. My son, who is 10 years old, I had him outside looking at migratory patterns of certain butterflies, and then, just taking the data, being part of the NASA GLOW program. So, you want to be involved, but also ask questions, talk to your parents, maybe have a dining room discussion at the dinner table about, okay, what choices are being made? And is there any way we can improve? And that's something that, is great conversation. There's plenty of room for lifestyle adjustment, without a doubt.
That's great advice. And it looks like Melinda has dropped a link in the chat to climatekids.nasa.gov. So I'm sure there's a bunch of good information in there as well. I'm seeing one more question from Jessic, and they have a question about the extent of flooding that may occur. I know you touched on this a bit. When you showed that graph, I was surprised. I knew Miami was at risk, but New York was number 3. And you think of the population density and the importance to the world of a city like that. I wonder if you could talk a little bit more about coastal flooding.
Sure. Coastal flooding due to sea level rise is a major concern, because as you look on a map, the most populous cities around the world are around the coast. And there's a lot of reasons for that, transportation, but also where settlements were. But when you take a look at some of the most populous nations that are being threatened, by population, you're looking at certain parts of India, parts of China, that are radically concerned. Now, there's a huge hope this week. The president of China and also John Kerry met, and they started talking about, okay, how do we change it? Because remember, the two biggest polluters are China right now, number one, and the U.S. is number two. So the reason why I'm very strongly opinion about this is that we have to change within the U.S. to make a global leadership example, but also have the impact, without a doubt. And there's plenty of information on the web as far as like, okay, what are the models projecting, and what can we do about it?
That's great. Yeah, certainly some positive steps happening this week. Dan, that looks like all the questions. Right now we have some folks, Oliver says that they try to shut off their lights when they leave the room. Ryan says they're not doing anything yet, but hopefully your program today has motivated Ryan and other folks watching from home to take some small steps to help combat climate change, whether it is turning off the lights when they leave the room or planting a tree, getting involved and educating themselves. We hope all of you watching from home will take that first step, especially here on the 51st Earth Day, to help us solve this really important problem. So with that, Dan, we'd like to thank you for participating in the Triangle SciTech Expo. I really enjoyed your talk. I hope everybody watching at home enjoyed it as well. If you folks are interested in watching more, we have a couple more days of programming. You can go to the museum's website to see the entire schedule of events, and we hope to see you at another one. Thanks for participating.
Thank you for having me, and don't forget, every day is Earth Day. All right, have a great day. Take care.
Thanks, Dr. Porter.
Bye.